Across the universe, there exist objects so powerful that nothing can escape them. Not planets, not stars, not even light.
They are among the most mysterious and fascinating phenomena in the cosmos. They are called black holes.
Welcome to Give Me Space, where we explore the universe and everything you need to know about it. And if you enjoy discovering the incredible science behind space, make sure to subscribe, because the universe still has many secrets waiting to be uncovered.
A black hole is a region of space where gravity has become so strong that nothing can escape its pull. This happens when a huge amount of matter becomes compressed into an incredibly small area. The result is a point of extreme density, known as a singularity. Around this singularity lies an invisible boundary called the event horizon.
This is the point of no return. Once something crosses the event horizon, escape becomes impossible. Even light, the fastest thing in the universe, cannot break free from the immense gravitational pull of a black hole.
That is why black holes appear completely dark. They do not emit light. They trap it.
Most black holes are born from the deaths of massive stars. When a star many times larger than our sun reaches the end of its life, it runs out of nuclear fuel.
Without energy pushing outward, gravity takes over. The star collapses inward under its own weight. In many cases, the collapse triggers a massive explosion called a supernova.
What remains after this explosion is the collapsed core of the star. If the remaining core is massive enough, gravity continues crushing it smaller and smaller. Eventually, the matter compresses into an incredibly dense point.
At that moment, a new black hole is born. The most important feature of a black hole is its event horizon. This invisible boundary marks the distance from the center where the escape velocity becomes greater than the speed of light. Inside this boundary, every possible path leads inward.
If a spacecraft approached the event horizon, things would begin to behave strangely. Time would slow down. Light would bend. Space itself would stretch.
To an outside observer, the spacecraft would appear to freeze in time near the edge of the black hole. But to the astronaut crossing the boundary, time would appear normal. Once inside, there would be no turning back. Near a black hole, gravity becomes incredibly uneven. The force pulling on your feet would be stronger than the force pulling on your head. This stretching effect is known as spaghettification.
Anything falling toward a small black hole would be stretched longer and longer until it becomes a thin stream of matter. Even atoms could be torn apart by the extreme gravitational forces. Fortunately, this process would only occur very close to the event horizon.
Farther away, the effects of gravity would feel more normal.
Not all black holes are the same. Some are relatively small, only a few times the mass of our sun, but others are truly enormous. At the center of most galaxies lies a supermassive black hole. These giants can contain millions or even billions of times the mass of the sun. At the center of our own galaxy, the Milky Way, lies a supermassive black hole known as Sagittarius A star. Despite their immense gravity, these black holes do not consume entire galaxies. Instead, they act as powerful anchors that help stabilize the structure of the galaxy itself.
Although black holes themselves emit no light, they can still be detected. When matter falls toward a black hole, it often forms a rapidly spinning disk of gas and dust known as an accretion disk.
Friction within this disk heats the material to extremely high temperatures. The result is some of the brightest radiation in the universe. In fact, the regions around black holes can outshine entire galaxies. In 2015, scientists made a groundbreaking discovery. They detected ripples in spacetime known as gravitational waves.
These waves were produced when two black holes collided billions of light years away. The collision released enormous energy, briefly producing more power than all the stars in the observable universe combined.
The discovery confirmed a prediction made by Albert Einstein nearly a century earlier.
For decades, black holes remained invisible to direct observation. But in 2019, astronomers achieved something extraordinary.
Using a global network of radio telescopes called the Event Horizon Telescope, scientists captured the first image of a black hole. The image showed a glowing ring of gas surrounding a dark shadow.
This shadow marked the event horizon of a supermassive black hole located in the galaxy M87. For the first time in history, humanity had directly observed one of the most mysterious objects in the universe.
Black holes may sound terrifying, but they are not cosmic vacuum cleaners. If the sun were suddenly replaced by a black hole of equal mass, Earth would continue orbiting normally. Gravity would remain exactly the same. The real danger comes only when objects move extremely close to the event horizon. Fortunately, the nearest known black hole is thousands of light years away.
For now, our planet is perfectly safe. Even black holes may not last forever. According to a theory proposed by Stephen Hawking, black holes slowly lose energy through a process known as Hawking radiation.
Over immense periods of time, trillions upon trillions of years, black holes could gradually evaporate. In the far future of the universe, they may be among the last remaining objects.
Black holes challenge our understanding of physics, gravity, and the very nature of space and time. They are invisible, powerful, and endlessly fascinating. And yet, they represent only one of the many mysteries hidden within the universe. If you enjoyed this journey into the depths of space, make sure to like this video and subscribe to Give Me Space so you don't miss the next episode. In our next video, we'll explore another incredible question. How big is the universe, really? Until then, keep looking up, because the universe is far bigger and more mysterious than we can ever imagine.